Alright, hello everybody, and today we're going to be having a look at the definite integral. So if you remember from the last video, we managed to find this little formula right here, which will give us the area underneath the curve between 2 points, A and B, like so. And in this video, we're going to be having a look at how we can use the definite integral, which I'll be going over momentarily, and how we can use that to evaluate areas underneath the curves. So you'll know that if we have the integral of some function, let's say x squared, like so, all that means is take the antiderivative of x squared, and you can use the reverse power rule for that. And just as a quick recap, if you have x to some power, all you need to do is add 1 to that power, so 2 plus 1 is 3, and divide by the new power, which is 3. And remember to add your constant. So this integral right here, this is what we call an indefinite integral. And the reason being, it's going to give us a primitive function. And remember from the last video, the primitive function is actually the function that's going to help us find the area underneath the curve. So you can kind of think about the indefinite integral as just giving us a kind of general formula in order to work out the area underneath a curve. And how about the definite integral then? Well, the definite integral will look a little bit different because it's still going to be our integral. Let's use the same function x squared, but instead of just having this integral right here, we actually have upper and lower bounds, and you'll see these numbers written from the bottom up to the top. So let's say, for example, from 1 up to 4. And whenever you see this, this is called a definite integral because our integral right here actually has numbers on the top and the bottom. So this is what we call the definite integral. And what the definite integral does, it's not going to give us a function that can help us find the area underneath the curve. It's actually going to find the actual area. So if you imagine this integral right here, what it's actually doing is we have our function x squared, like so. So this is our function x squared, and it's finding the area between 1 and 4. So this definite integral right here is actually finding this area in here. So what exactly is the difference between these two then? This integral will give us a new function. So this integral will give us a function, whereas the definite integral will give us some number because that number will be the value of this area right here. So this is the definite integral, but how exactly do we use it then? Well, first of all, let me give you a more general case. If we want to find the area between a and b of any function f of x, remember from the last video that that area is given by this formula right here, which is f of b minus f of a. So the definite integral will give you the area, which is just this little formula right here. So that's pretty much what we're going to be doing with this example right here. So the first step is actually to find the antiderivative. So we already have it right here, which is x cubed over 3 plus c. And we're going to be evaluating this at the point b. So if we evaluate this thing at the point b, which in this case is 4, we're just going to replace this x here with a 4. And we have to subtract off capital F at a. So we're going to subtract off our capital F right here, but evaluate it at a. So if we plug 1 into here, we're going to get 1 cubed over 3 plus c. So I hope you can see where I'm getting everything from. These two parts right here is just our primitive function right here, or our antiderivative, but I'm just plugging in 4 and 1 into these x's right here. So whatever this thing evaluates to is going to give us the area underneath our curve right here. So let's actually just simplify things a little bit. So 4 cubed, that is 64 over 3, and then we have a plus c, and then we have a minus, so we're going to have a minus 1 cubed, which is 1 over 3, and then we have a plus c right here, but since we have a negative, we're going to have a negative c. And you see, the nice thing is we have a positive c and a negative c, which will actually cancel each other out, which is really quite interesting. So all we're really left with is 64 over 3 minus a third, which will give us 63 over 3, which will give us in the end 21. So what did we just find right here? We found that 21 is actually the area underneath this curve x squared right here. And the even more interesting thing is that these c's will cancel out. So what exactly does this mean right here? It means that no matter what value of c we have in our antiderivative right here, they're going to cancel out in the end when we compute the definite integral anyways. So in fact, we actually don't even need to put these c's right here because they're going to cancel out anyways. So when we compute definite integrals, the main part we need is just this x cubed over 3 right here. We don't need to put the extra c down. But for indefinite integrals, when we're just anti-differentiating, we do need to put down the c.